Okay, so today we're going to look at the definition of a function and then different notation and things like that as far as functions go that we'll need for what we're going to do for the rest of the semester. I'm assuming that all of you have worked with functions before, but we're just going to kind of quickly run through the definition and all of that just to make sure everybody's clear on it. As far as it goes, there's lots of ways to define a function, but for the purposes of this class, we can just say a function is a rule that associates each element of a set X with only one element in a set Y. Okay? A function is a rule that associates each element of a set X with only one element in a set Y. We're going to look at a few examples to start off with. Maybe we have this. Say I have a function, set X and a set Y. And I have 1, 2, and 3 for X, and 4, 5, and 9 for Y. If I want a function, I need to associate each element here with one element here, so I can just do something like send 1 to 4, 2 to 9, and 3 to 5. Then each element here goes to only one element here, so it's a function and we're good. A couple other examples just to make this clear. Suppose we have another set X and Y. Let's see, for X we'll do 3, 1, 4. For Y we'll just do 6. And then for our rule, we'll send 3 to 6, 1 to 6, and 4 to 6. Is that still a function? According to the definition, the rule associates each element of a set X with only one element in a set Y. In this case, each of these X's is associated with one Y. 3 is associated with 6, 1 is associated with 6, 4 is associated with 6. The fact that all the X's are associated with one Y doesn't matter at all. The definition just says each X goes to one Y, which is what we have, so that's a function. One more example. Suppose we have X and Y, and in this case we'll say X is 1, 2, Y is 1, 2, 3, and we'll do something like this. Now, 1 goes to 1, 1 goes to 3, and 2 goes to 2. Is that a function? According to the definition, it's a function if each X goes to one Y. In this case, this X, 1, goes to two different Y's, so that's not a function then. So this one doesn't work. There's kind of a fundamental and really important difference here. Several X's can go to the same Y, and that's okay, that's still a function. But each X can only go to one Y, or it's not a function. So just make sure you understand that distinction. As far as it goes for this class, there are different ways to look at functions and define them and determine if something is a function or not. We're really not going to do problems like this. This is just to give us an idea of what the definition is. And we're not really going to focus on the algebraic way to determine if something is a function or not, because we don't really need it for the purposes of this class. We're going to look at things graphically. So, suppose we have, we started this semester talking about lines. So suppose we have a line right there. Is that a function? The definition says it's a function if each X goes to one Y. Well, if I pick an X right here, it goes up to one Y. If I pick this X, it goes to one Y. Pick this X, it goes to one Y. So according to the definition, that would appear to be a function, and we're good. Suppose we did parabolas. So I have a parabola that looks like this. Is that a function? We'll do the same thing we did before. This X right here goes to one Y. This X over here goes to one Y. This X right here goes to one Y. So sure, each x goes to 1y, that's a function. I'll point out, if you go to this x, like right here, then these two x's go to the same y. But that's not a problem. Different x's can go to the same y as long as each x only goes to one y. One more example, because we just finished talking about circles. Suppose I have a circle. Is that a function? It should be pretty obvious. If you pick some x, like this one right here, it goes up to that y, it also goes down to this y. So this x is associated with two y's, so it's not a function. One thing I would point out, and we're going to come back to this, technically there are actually points right here on the end. Those x's on the circle do only go to one y, but that doesn't matter. As soon as we can find one x that goes to two different y's, it's not a function and we're done. Other than the circles that we looked at in the last section, we're really going to restrict ourselves in this class to functions, so we won't really need to worry about it all that much. As far as it goes to determine if something is a function or not, we have a test. We're not going to do the algebraic test, we're going to do the graphical test, and it's what's called the vertical line test. I'm sure you've all heard of it before, but just in case, it says if a vertical line touches your graph more than once, it's not a function. If a vertical line touches your graph more than once, it's not a function. So just to see how it works, to go back to the ones we just had. If we have some line, I want to know if it's a function. No matter what vertical line I draw, every vertical line will only touch it once, so it's a function. If I do the parabola, no matter what vertical line I draw, every vertical line only touches it once, so it's a function. The last one we just did was a circle. And again, it's easy to see if I draw this vertical line, it touches the graph twice, so it touches the graph more than once, so it's not a function. Again, I'll point out, you actually can draw vertical lines here and here. They're called tangent to the circle, right here and right here. They only touch the graph once, but that doesn't matter. As soon as I can find one line that touches it more than once, it's not a function anymore. Those tangent lines become important later on in calculus. But as far as this class goes, if you want to know if something is a function or not, use a vertical line test. Graph it, throw it into your calculator, graph it on a piece of paper, do the vertical line test, say yes it's a function or no it's not. Okay, now as far as it goes, there's a lot of notation for functions that we need to know. First off, function notation. We're used to seeing things like this, y equals 2x plus 3. Now we want to write that in function notation, and all you do is you replace y with f of x. That is not f times x, this is notation, it's the function f of the variable x. And all it really means is I have this equation right here, this function right here, with a variable x. And if I then write something like f of 2, it means take this function f of x and replace the x with 2. So we get 2 times 2 plus 3, which is 7. Just to make sure we're clear on this, really quickly, if I want f of 4, I get 2 times 4 plus 3, which is 11. But I don't have to use numbers. I can do f of delta. The function takes whatever I plug in, multiplies it by 2, and adds 3. So if I plug in delta, I get 2 delta plus 3. It doesn't matter. Whatever I plug in gets multiplied by 2 and added to 3. So if I have f of x plus h. The function takes whatever I plug in, multiplies it by 2, and adds 3. So I get 2 times x plus h plus 3. I can plug in whatever I want. All I do is replace x with whatever I put in here, and I'm done. So, one more example, just to make sure we're fully clear on this. Suppose I have f of x equals 2x plus 5, and another function g of x is equal to x plus 1 squared minus 2. I want to find 2f of 3 minus 4g of 1. All we do is substitute. 2 f of 3. F of 3 is f of x when x is 3, so that's 2 times 3 plus 5, minus 4g of 1. G of 1 is g of x when x is 1, which is 1 plus 1 squared minus 2. And then just do all the math out. 2 times 3 is 6, 6 plus 5 is 11, 11 times 2 is 22. 1 plus 1 is 2, 2 squared is 4, 4 minus 2 is 2, 2 times 4 is 8. So we get 22 minus 8, which is 14. And there we go. Function notation and evaluating functions using function notation, adding, subtracting functions, plugging things in. We're going to do all of this, so I just want to make sure we're clear on it because we need to know how to solve it. There's a few more properties of functions we need to go over, but I'm going to stop this and start another video because this one is rather long as it is.